I know, and I forgot to do it. Yeah.
Oh, yeah.
I know. I just gave you all zeros on it. Yeah, we're dealing with Monkey Kings and 200.
It's like in Alice in Wonderland.
What's up?
Mad Hatter.
This is tic-tac-toe, actually. Yeah, the Mad Hatter and the Monkey Kings are the pieces. Yeah, see, I'll show you. This is the actual game. So these are the Monkey Kings, and this is the Mad Hatter. But then we're converting this over to Java.
4K, 60 FPS.
What's this?
I said, is that 4K, 60 FPS?
60 FPS. Yeah? Really? Oh, awesome.
I don't understand what's going on here.
I'm playing tic-tac-toe.
It doesn't
Oh,
look
it's
like
tic-tac-toe.
Yeah, when you make your move, they alternate colors. Oh, then we had let's see, do I have the message on here? We had the wedding at sea. I don't have it on here. Mr. Gonzalez and Aunt Jemima got hitched. Let's see. It was actually a wedding chapel. There's them outside the wedding chapel on the ship. I presided. I'll put them up on Facebook. But then there was an incident. Cousin Lupe showed up. Yeah, we have a new member.
I can see you doing this.
Man removes muscle to see what human flesh tastes like. Yeah, there's Lupe. You see Lupe?
Oh, they had a third?
Yeah, he's the cousin. That's cousin Lupe.
Oh, cousin.
He's Mr. Gonzalez's cousin. And he didn't approve of Aunt Jemima for bad reasons. See, Lupe is a Klansman.
Oh.
No offense. So I built a pretty deep backstory for Lupe on the trip. And then my wife got mad at me when I was telling the waiters at the dining room table on formal night about this.
Well, without the backstory, just...
Right, it doesn't make any sense. So I had them at the table with us. I was carrying them around in my spa bag. Let's see.
What ship was this?
This was the Regal Princess. Yeah, see, there they are. That was after the wedding. They were on their honeymoon going around. Yeah, so she was embarrassed that I was telling the crew, everybody I walked into about these stuffed animals. And yeah, it was actually kind of alarming how upset she was.
As if they weren't real.
Exactly. Like, what do you mean? And she wanted my permission to like pack them in the suitcases because you have to put your suitcases out the night before you leave the ship. And she said you're not going to make it. She wanted to make sure I wasn't going to make them talk and make her feel guilty in the middle of the night. Because that's what I do.
Which you obviously did.
I did. There's something so wrong with me. It's just terrific. All right. So let's talk about Syria. Where are we at here? 200 this morning. We were looking at maps.
Planning your next cruise?
No, they were we were looking at where the prison was. So they were down here in Guatemala. They were somewhere in here, and I decided that I was probably somewhere in here at some point. Well, they were getting stuck in Guatemalan prisons and stuff. Something. All right. So let's see. What's the name of the thing we use? Cloud9.
C9. ID C9.
Yeah, just go off. No, keypad.
There it is. There.
Nailed it.
Who stole his account?
Oops. C9.
Am I in?
You just have to actually open.
Right. So I'm having alcohol withdrawal.
We could just go to Island House and fix that.
To detox my liver. Well, you got to get your money's worth when you get those all-you-can-drink packages on the ships.
I'm pretty sure you get your money worth in the first
How much
hour.
is your money's worth? The money's worth, you have to get more than 5 drinks a day, doesn't it?
Oh, that's not a problem.
5 drinks, I can do that.
So like I said, the first hour.
Yeah, didn't you like drink?
Yeah, the last cruise I had 103 drinks in 7 days. The problem is that since I have such a slow metabolism, like it doesn't affect me. So I'd have to worry more about getting full. So I start off with just martinis, just chugging martinis. Well, no, I do like the flavored foo-foo ones. You know, like they basically just yeah. I had an appletini. I had chocolate ones. I had a watermelon one.
Some shots of Jaeger.
Oh, God.
But then I would drink at night. I do a lot of champagne with dinner. So yeah. So I just bring a whole bottle with me, just stumbling around the boat. cousin Lupe, you trying to break up the wedding? What were they doing? Let's see. We need to open up our. I think I have. I had that on there, didn't I?
Yeah.
Yeah, why didn't
It didn't have a conversion?
that could have been the
Yeah,
deal.
you did.
Octal to hex. No,
Well, that's
hex to
right.
octal.
Yeah.
Should have foreseen that there would be one.
Although I think I messed that one up, and I thought I did it perfectly, but then I actually looked it up afterwards, and I was like off by a I forgot a one in its first place or something.
I did the same thing.
You did the same thing.
All right.
Oh,
And then, so I have this, and then there's a slide set we've been working through, right?
Yeah.
Yeah, in Blackboard. Isn't it a book?
Well, I have the book open right now, but I thought there was something else we were going through. Oh, I saw a bunch of movies on the cruise ship. This was the first ship I've been in that had like in-room like first run movies that were just included.
Like any good ones?
Yeah, I watched like a ton of movies. So I can probably name. Let's see. Let's go through them. I saw the newer Terminator movie, which was actually better than it should have been. Have you seen it?
Yeah.
Yeah. It was better than it should have been.
Oh,
That's true.
yeah.
Let's see. So then I saw, was it Bridge of Spies?
That one. I thought
That was good.
I love that.
I saw the Bobby Fischer story, the chess player during Cold War.
Mhm.
That was actually really good. It had he was the first U.S. Grand Champion chess player. The guy was like nuts. So that was actually pretty good. I saw the 33, I think with the guys in Chile, the miners get buried.
7 hours? Oh, no.
Yeah, they get buried and it's like 70 days. That's not that old. So that movie came out like 6 months ago. What's this?
You thought you were talking about the restaurant. Like 33 people trapped in Chile.
That's pretty weird.
They
That'd be an awesome movie.
ran out of ribs.
There's a finger on my chili.
that's a pretty awesome movie. Let's see what else. Into Darkness, the Star Trek movie.
It came out a while.
Yeah. I hadn't seen that for some reason, but that was good. Ant-Man, thought that was good. That was a lot better than it should have been.
Yeah, that was surprisingly.
Ant-Man? Yeah.
Wow.
That movie surprised me.
Let's
Going to
see.
Batman versus
I
Superman.
saw Hitman. That was mediocre at best.
Yeah.
It was just like action.
Yeah.
And we expect to take from video games.
Let's see. I saw the Mockingjay 2, the last one, very last one.
That was just a mess.
What-
Money grab.
It was like story was like pretty consistent. The third movie was just like, okay, we're going completely.
Well, that's from the books. I mean, it followed the books.
Doesn't mean the story is just like.
Well, yeah, I mean, but they took one book that was already kind of a short, storyless book and split it into 2 movies.
Yeah.
I mean,
They're doing that with
out of the 3 books, the third book was definitely the most boring.
like the latest Divergent series or whatever.
Yeah, I heard.
They do that too. They split it into 2 parts.
That's the way it should be.
The movie literally just like tanked. They split it into 2 parts.
Did you see it?
No,
No, they didn't split it into 2 parts. That was the second book.
no, they split this last movie into 2
Oh,
parts.
I see what you're saying. Yeah.
Like they do with all their other lines.
It's the way it should be.
Any trilogy goes to 4 movies.
Money.
The only movie series to do that right was Harry Potter.
Yeah, I think so.
Deathly Hallows.
They're coming out with a new Harry Potter series.
Yeah.
Oh,
Oh, you're stoked?
oh yeah. They're coming out with the Fantastic Beasts and Where to Find Them too.
Yeah.
Yeah, but that's not Harry Potter.
It's Harry Potter world.
Yeah.
It's in the
Yeah,
universe.
right. Well, what does that even mean?
It means it's in the universe, but it's like
It's
it
like
has nothing to do with
Star
Harry
Trek, okay?
Potter.
You
Yeah,
got-
the universe
old Star
exists.
Trek
It's like exactly like Star Wars
Harry
too.
Potter
exists.
Well, but isn't that what is happening with all these other movies like the Marvel universe and stuff like that? They just come out with
Yeah.
What else is a franchise? You build a universe, like you build this Marvel universe. You're not just gonna discard it when you go to make a new movie. You're gonna
well, except Star Wars.
Or Spider-Man.
When Disney bought Star Wars, didn't they get rid of like half the canon?
I didn't think so.
Or by half the canon, I think like 90% of the canon.
They got rid of like everything.
There were all these books and stuff that were considered to be part of the canon beforehand,
Oh, I see what you're saying.
and they basically just said everything's just what's in the movies. That's the
Yeah.
canon. Everything else.
Yeah, but it's still Star
There's
Yeah, see,
quite
it's
a
still
bit
Star
that's
Wars. It's still canon just to the movies. Disney didn't want to have to deal with that canon. Which I mean,
There's a lot of problems
Yeah, I
with
saw
it. I mean, there's a lot of good things in that canon, but there's also a lot of problems. Like I was.
The universe is just imagine they split. There's now 2 universes.
And plus, why don't they have? I mean, since we're doing all these like didn't they had like Aliens versus Predator, right?
Yeah, don't talk about that.
Yeah. Then they had then we have Batman versus Superman. Why don't we have Superman versus Aliens?
Well,
Or
Superman
Batman
is an
versus
alien.
Batman versus Predator.
yeah, it's
Superman is an alien.
It's a good question. We should have that.
How many of you in here would not go and see Batman versus Predator?
Who wouldn't?
Pretty much Batman versus anything. Like anything versus
Why would
anything.
you go see Pacific Rim? It's just a bunch of monsters beating up a bunch of robots.
Pacific Rim was actually pretty decent.
Yeah, they canceled the second one.
Really?
In production, they canceled it.
No, it's back on.
It's back on?
It's back on.
Woo! Hype train, re-railed.
I'm getting rerailed.
You almost never get to say that. It just gets derailed and then it ends. But
Or what, like Ant-Man versus Papa Smurf or something?
Del Toro isn't directing it though. They're giving it off to someone else.
Who cares? It's gonna be just giant robots
It's
fighting
gonna
stuff.
be
yeah, it's not those movies. I don't really care who the director is.
Yeah, you don't want a
It's gonna
storyline.
have Idris Elba. Oh man.
About I don't know, Terminator versus Harry Potter.
You can't like
This is-
commingle like that because then it becomes like a does magic really affect this or like what counters what? It's like a game of.
This
second
is the
grade.
Transformers. All right, fine. Terminator versus Transformer.
Transformers would
Harry
obviously
Potter.
Transformers. Wow, that's something I'd have to see.
Yeah, like the next movie, like all of a sudden, like one of the, you got these guys turn into cars and planes and stuff like that, and then one dude just turns into Harry Potter. Expelliarmus!
Just imagine like a naked Daniel Radcliffe falling out of Optimus Prime's chest.
Oh. Let's see. We were talking about pipes last, right?
Thought we were talking about Batman versus.
And then I think I said we were going to start talking about mutual exclusion. Sharing a pipe. All right, Evan, you're up.
What do you want?
You know a lot about sharing a pipe.
You kind of
You forgot.
All right. So last time we talked about the nature of the fork command because we are kind of stuck on that for all sorts of reasons. And we talked about when you initially establish a pipe, you do this through an integer array. All right, so this guy can I just download this? Save. Downloads. That's way better. All right, so this is an integer array. We've already seen that integers are shared when we fork, right? Because we get a copy of those values. Those are primitive type values. They're not pointing to memory addresses. We get they're passed by value when we call functions. They're passed by value when we're splitting them between a parent and a child. We then take this this two bucket integer array, and we turn it into a pipe using the pipe system call. So what this guy does is he fills up this array with unique descriptors for our two sides of the pipe. So let's look at that here. I'm going to rewind a little bit and do a couple of these things. I think we actually already had a example dealing with pipes, didn't we? That's shared memory. Well, here, I'm just going to steal this. And here's pipe example. All right, so before we do anything else, let's just do this. I'm going to comment out most of this stuff. Just as a reminder, and we'll go ahead and do a printf. Pipe 0, %d, and this is going to be file des 0, and then we'll do pipe 1, and this will be file des 1. And I'll actually do the same print before we turn it into, before we apply the pipe to it. We should see we get, it'll more than likely just be a couple of zeros, but potentially it could just be gibberish. older C compilers would not necessarily rely on a default value. I'm pretty sure this guy should give us 2 zeros. So we should see 0, 0, and then we pass it to the pipe system call, which should then give us a couple of real deal things. Let's see. How do I get to the window? New terminal. Really? Are you sure that works on the C programs? Well, I don't really want to do that anyways, but we'll do it. It did work. Yeah, I don't like that. Well, and it only sort of worked. Oh, let's do \ns on those so we can actually kind of sort of see it, read it. Oh, that's not going to help. Recompile, run. Oh, good. So it did give us random crap. All right, so when we first run this, before we pipeify the two bucket array, we have just random values in there, left over from the last time that memory address was used. Then once we send it into a pipe, notice we have 2 file descriptors, a 3 and a 4. Now when we hear file descriptor, file descriptor should be a term that's synonymous with what as it relates to POSIX systems. We've been talking about universal I/O, right? So file descriptors are kind of our magic ticket for all sorts of universal I/O stuff. So we have file descriptor 3, file descriptor 4. This is the multiple ends of the pipe for reading and writing. All right, so come back in here. I'm going to, well, we'll uncomment some of this stuff, but I'm going to, actually I'm going to only uncomment portions. I'm not going to use this buffer right this second. We'll go ahead and fork. I won't use that. I will print both of these things out. What's this? I will. Just for you. All right, so this should show us what we already know, and we don't need these two. We've seen that's gibberish. That our file descriptors are shared, but they're shared not because it has anything to do with pipes. It's shared because they're integers, right?
Actually, you just mean copy.
That's it. That's it. Yeah, it has absolutely nothing to do with the fact that it's a pipe. It has everything. If we just had int A, int B, they would have those values because they are shared. They follow through, but they each get a copy of it, just like everything else as a result of the fork command. All right, so there's our 3.3 and our 4.4 for the 2 sides of the pipe. So both the parent and the child both know about that guy. All right. So now let's go back into this here. So that's our sharing of the pipe, so we understand how that works. Closing file descriptors, that's something that modern Unix systems won't require. We should still do it as good Samaritans, but it's not required. Okay, so here's our I/O on these guys. We've seen these reads and writes, standard universal I/O stuff. We were reading into, I think last time we did this, weren't we reading into just a buffer? Yeah, so here's a string buff that was hello. We went ahead and wrote to that guy we wrote to file descriptor 1, whatever was the buffer, and this is how much we were writing, 5 bytes, number of characters that were in there. Then we went ahead and we memory allocated, so I was introducing malloc kind of off of our shared memory example. So we memory allocated 5 times size of char, which would come back as a 1. That's what that would ultimately be. So this would give us enough new memory to hold 5 characters. And that's going to be our buff 2. This is the same thing as just saying char pointer buff is the length of buff 2. And then what we did here in the child is we read from the other end of the pipe. So if we look at the picture here, see, this is 1, this is 0. So we can read from 0, we can write to 1. That's how we get information piped into the other guy. So we read from 0, that is this end right here. That's the child reading from the pipe. And then we'll print out what we read. We read into our buff 2. And then we went ahead and wrote into 1 woot. All right, so the child read from here but wrote in here. So just because the child process in this particular case is choosing to read from 0, but detach the idea of a parent or a child from this example and just say, here's a pipe, it has 2 ends. This is, the bottom is 0, the top is 1. You can think of it as like that, the left, the right, however you want to you think about it. But both, in our case, both the parent and child have access to both ends. But it flows in one direction. So we always write to 1 and read from 0. Okay, so we read from 0 here after we wrote to 1 up here. So this should read into buff 2, our hello. Then we go ahead and we print out what we should have read in there, which is hello. And then the child is going to write woot, which is 4 bytes, onto our pipe. What's the parent going to do? Well, we had our parent saying, I'm the parent. I said, here's the number of things I read. We had a busy wait loop here. So while num read is equal to 0, we're doing this. So while num read is equal to 0, we're going to say num read is equal to, using universal I/O, reading from bucket 0 into buff 2, 5 bytes, a maximum of 5 bytes. And then this guy should ultimately return the number of bytes that was read. So this should read over and over and over and over again. But now we have a problem. What we're trying to do is we're trying to create two-way communication between our parent and our child through a pipe. Make sense? Okay. But we're trying to do this right now with just one pipe. Okay. And this pipe is, we could say, theoretically shared between the parent and the child. Even though they just both happen to know at the operating system level the unique identifier of the 2 endpoints of our pipe, position 0 and position 1. All right, so having said that, what's going to happen here? Remember, what's happening inside of this if statement and what's happening inside of this else are happening simultaneously-ish. Right? These are 2 separate PIDs, 2 separate processes running on the operating system. And they're getting CPU time whenever they get CPU time. And in a multi-core processor, these guys could very likely be getting CPU time at the exact same time. So they're both trying to read and write from the same pipe at the same time, at least potentially. All right, so what can happen here? Well, we do an initial write to that pipe before we ever split. Before we ever fork a child process, we do a write. So we know we have the string hello sitting on the pipe right now. Okay? Then we split, and now it's a race. So we probably started talking about race conditions last time before we talked about the exam. So now there's a race between the child and the parent. Who's going to read first? Is the child going to read in the hello and print it out? Or is the parent going to read in the hello and print it out? So just for the sake of argument here, let me do this. I'm just going to steal that code. We're going to do this. What's this?
I'm not racist. I'm just against race conditions.
Oh, I told you about Lupe, right?
Yeah. It was like 30 minutes ago.
Because he is against races. I told you that part, right? I'm a little.
Did now.
Well, I don't remember. I've told this story several times today. You can't help it. He came from a very. Huh?
You get to hear it again tonight.
I don't know. I mean, I'll be here tonight. Well, parts of me will be here, I suppose. It's just twitching out over there. Nick Schumacher picked me up from the airport last night late, and I mean I was so tired. I only remember being this tired one other time, and that was the day I was born. And
You're more tired than like at the hackathon?
it was ridiculous. I don't even understand how I was that tired. I think I may have caught something on the island, but not like a normal.
Unrelated.
I have a picture of that too, so I can show you that to you after class. What's up?
Get your penicillin shot.
No, I didn't, and I actually, if any of you are familiar with rashes, I need something identified.
Where is it located?
It's in my phone. All right.
Wait, did you take a picture and it happened to be in
I didn't take the
or did
picture.
you take a picture of the rat?
I didn't take the picture. Tabby, across the room.
Across the room.
Full zoom.
I get close to
Oh, so anyways, I was saying Schumacher picked me up from the airport, and I assumed he was probably going to drive back, but he picked me up in my car. He just went to my house and grabbed my keys, and but he didn't. He wanted me to drive, and I felt okay when I got off the plane because you just got your luggage, you've been moving around and stuff. He told me I was slurring my speech and was all over the road. I asked my wife. She said it was she didn't notice when she was sleeping. So I told you I was having alcohol withdrawal.
You're still drunk.
That's what the flight
No,
was.
nothing yesterday.
Nothing on the flight?
They shut down the bars the day you disembark. They don't want you using your. Oh yeah.
Like the 7th inning of Bruce game.
It's the same thing. Okay. So in any case, we're writing once up here. Writing one time up here. And this is before there's two processes. So we effectively, in this example, have hello sitting on the pipe. Waiting to be read. Okay? Now, we split the child and the parent. So this is child, this is parent. And we prove that we have the same pipe IDs. Let's actually just get rid of that to keep the chatter down. We've all been convinced that that information was passed along. All right, so now both the parent and the child are both going to try to read from the pipe, the exact same end of the pipe at the same time. Okay, well, potentially at the same time. And then they're going to print out whatever they read. All right, and let's, for right now, not write again. So let's just create the scenario here. All right, so go ahead and compile this and run it. The parent got hello. Hold on a second. Parent, child. I kind of wasn't expecting that. Write once. Fork. Shall we read into buff 2, which we can say maybe was shared, but it shouldn't have been. Let's just hope that that's the case. So child, that guy is a char array, so let's just say %p for the pointer, and we're going to print out buff 2. And that should give us the memory address of our buffer. We'll do the same thing up here, but for the parent. So even though we're calling malloc once, when we, oh, wait a minute. Actually, this should definitely be different because we actually did this after we split. So both of these guys should individually get their own buff too. So I'm wasting my time doing this. It's not even in question. All right, so both the parent and the child have their own version of buff 2 because they each went through the process. This was not a shared variable. This came after the split. All right, so they each created their own version of buff 2. Here, the child will read into buff 2 up to 5 bytes and then print out what they read. The parent will read in from buff 2 up to 5 bytes and then print out what they got. All right, good. Now it is what I expected now. All right, so parent says hello. We'll run this multiple times. All right, so consistently parent is getting the hello, but we're never seeing the child. Why is that? What's happening? What do you, since we never see anything print here, this is the child side of things. We try to read in up to 5 bytes, and then the child should be printing something, right? We're never printing anything. I mean, forget about, let's just take that out for a second. That's all this guy does is print the word child. Run this again. We never get to that line. What does that tell us about this line? What does that tell us about this? If we're never getting to this line right here. Just
It's waiting for more. It's waiting to be able to read something.
Yep. So here I'll move the child beforehand to prove that we are getting into this if statement. All right, so now we should see child and we should see the parent. This potentially actually could cause enough of a delay that because I/O is expensive. No, it won't. We'll still read first here, so this won't make a difference for the who gets the read. What row? That is not what I was expecting. Yeah, I definitely saved it that time.
Does it have anything to do with that it's an int and not the... Isn't it supposed to be some special thing?
Does what have to do with it?
The PID. I think before you had it like PID underscore key or something like that.
Oh, for the type?
Yeah.
Yeah.
So we had a PID type?
Yeah.
Well, it really actually shouldn't. It shouldn't make a difference. Because PID type is an int. Do. Dooby-doo. Yeah, that should have worked fine. Here, let's just do a print F PID is %D PID. So we'll leave it as PID type, which is just an enumeration for int. PID is 3012 for parent. This malloc thing break stuff? I mean, we should see this printed twice. That's kind of what fork does. Oh, well, no, this, we would see PID printed twice. I was thinking maybe this is the two numbers back to back. So this is where the split happens. We should have two separate I think we have that in here, don't we?
For some reason, if you read position 1 on the file descriptor of the child, everything works as normal. So instead of reading bucket 0, you read bucket 1 on the child, everything works as intended.
Let me just try something here. There we go. It was using a different version of fork. I didn't have the right library brought in. To be honest, I don't know what version of fork it was using. But I had to bring in I did a man on fork and saw that it was in Unix standard library. So I brought that in there. All right, so where we'll start next time is I want to get back down to this blocking thing. So I'm just going to put a big comment in here that I probably won't read. Show blocking. All right, so somebody remind me about that.
So.
All right, I'll see everybody on, see you on Wednesday. No homework because I got to get your exams graded.